Alright, describe if the function f of x is equal to negative 4x to the power 4 plus 3x squared minus 15x plus 5 is an even or odd or neither. What does this imply? Okay, so first of all, we can notice here that the degree of this function is 4. So this is an even degree function. So we made the statement that even functions have to have even degrees, right? So off the bat we can tell it's not an odd function, right? So because it's not an odd function, we just have to do the test for an even function. An even function just means that it satisfies this equation: f of negative x is equal to f of x, and all even functions have a line of symmetry, contain a line of symmetry along the y-axis. Okay, so what that means is that along the y-axis, it's just going to create a plane. So it's going to kind of look like this. So this is your graph, right? And you have, like, say this is your trace, right? If this creates a line of symmetry, didn't draw that out too well, between the two halves, right? Maybe if I just let's see if I could draw that a little bit better, right? So if this creates a line of symmetry between the two halves, then it's an even function, and the line of symmetry has to be along the y-axis. Excuse me. Okay, so this is the algebraic test to show that it's an even function. So let's test that out, right? So in this case, let's just use a different color for this. But in this case, let's do f of negative x. So we get negative 4 negative x to the power 4 plus 3 times negative x squared minus 15 times negative x plus 5. This is negative 4 x to the power 4 plus 3 times x squared plus 15x plus 5. And you can notice here that f of negative x is not equal to f of x because of the fact that the third term, this is positive 15x versus negative 15x, right? So because this is not an even function, and we know that odd functions have to have an odd degree, then we just simply say that therefore the function f of x, therefore f of x is neither an even or odd function, right, and is not symmetrical. Right? There is no line of symmetry that encompasses the function, right? Recall that for an odd function, there's going to be a rotational line of symmetry, so that what that would look like, right? This is your graph, right, and this is your odd function. There's a rotational line of symmetry along the origin. So what that means is that you could draw a line through the you can draw a line through the origin. You draw a line through the origin, and both of these ends here would be rotational lines of symmetry, right? So you could do that any sort of way, right? And basically these would be mirror images, but they would be symmetrical, right? So this is basically an odd function characteristic. This is an even function characteristic, and even and odd functions just have to do with symmetry. So the test for an odd function was f of negative x is equal to negative f of x, but it doesn't pertain to this scenario because it's an even degree.